Next up, we've got Nathasha Nahirnick. Nathasha is a Master's of Science student at the University of Victoria. She works in the Geography Department's Spectral Lab under Dr. Masira Costa, and her research investigates long-term eelgrass change in the Salish Sea and considers roles of human pressures on the nearshore environment. So, Nathasha, it's all yours.
Hi, thank you for having me speak today. I just wanted to say a little note about the title slide because I've been looking at this image forever, so it makes a lot of sense to me. But if you're going to do long-term habitat change, you have to assess your current distribution of that habitat in the present day. So a lot of my research ended up being on the methodology development in terms of using drones or unmanned aerial vehicles for mapping eelgrass habitat. So this is one of the images out of our drone surveys. So you have a bunch of geese up in the top left-hand corner there, and the band of eelgrass just below it. So if you are unfamiliar with eelgrass, it is an extremely important habitat for juvenile salmon as they are entering the marine environment, both for food and foraging opportunities, because eelgrass is an extremely productive habitat, but also for protection from wave action, from currents, and as well as protection from predators like seals and herons. And given the very large declines in seagrasses that we've witnessed all around the world, if there has been a decline in eelgrass over the long term, then perhaps this is a contributing factor to low survival of juvenile salmon. But currently we have very poor records of eelgrass change in the Salish Sea. So my research involved 3 study sites in the Southern Gulf Islands. We had Village Bay and Horton Bay on Main Island and Lyle Harbor on Saturna Island. The top map with the island overviews show you the watersheds that drain into each of these bays. And then along the bottom with the 3 bays, the green polygons are the eelgrass areas that we mapped in 2016 with the drones. And to do the long-term analysis, we used air photos dating all the way back to 1932, and then with 1950, 1975, 2004, and 2010, and then the most recent installment in the time series is our 2016 drone imagery. And from this time series of images, we derive 2 metrics to describe eelgrass change over time. The first is area, and as you can see in all 3 sites, we do observe a decline in eelgrass area over time. And this is about a 41% average over the 3 sites. It's also interesting to note for later that the rate of decline does accelerate after 1975. And then the second metric that we looked at was shape index. And this is a kind of perimeter to area ratio that we use as a proxy for fragmentation. So as shape index increases, as you can see it does in all 3 sites, that is suggesting that we're experiencing increased fragmentation of these eelgrass habitats. And for those 3 sites, it's an average increase in shape index of 76%. Now, the other part of my research was considering human impacts that could be playing a role in this decline that we're observing. And so when we look at human impacts with air photos, they have to be things that we can quantify from those air photos. And such we use a concept called landscape level coastal environmental indicators. And these are things that we look at cumulatively over an entire landscape that have very well documented impacts on seagrasses. So that falls into 2 categories. We have shoreline activities, and these are things that have direct physical impacts, such as harbor building, docks, boat scarring, anchor scarring, coastal infrastructure like protective infrastructure will change hydrodynamics and sediment regimes, as well as coastal log storage is a big problem in our part of the world, both for the scouring of the eelgrass meadows as well as the wood debris that is deposited into the coastal zone. And then the second category is watershed land use, and these are things that change water quality within a watershed that eventually makes its way down into the nearshore environment. And so for us specifically, we're looking at rural residential housing density because of the nutrient inputs that that particular land use will put into the marine environment, which then has implications for epiphyte growth and macroalgae, which will smother eelgrass, leading to decline. So these are the results from the landscape level indicators, and we have the residential housing density in the black line and the shoreline activities with the colored bars, and they're separated out by color into several different categories. And what we see is pretty much the same, with some differences between sites, but the same pattern is going on. And that is in 1932 and 1950, there's pretty much nothing going on, with a little bit here and there, but on the whole, there's not a huge amount going on. There is a fair amount of forestry going on, so that is definitely a thing that would need to have further investigation into, but these two indicators, not a whole lot going on. And then 1975 is definitely the turning point. You start to see some significant increase in both housing density and shoreline activities. And then 2004 through 2016, we see some pretty dramatic increases depending on the site. Now, we're not able to look at this information and say, this increase in housing density caused this decrease in eelgrass. There's way too many variables, such as herbivores, disease, climatic variables. But what we can look at from this is that the stress on the nearshore environment, according to these two indicators, has definitely increased, and that it's creating an environment that isn't necessarily becoming any more hospitable for eelgrass. Now, the landscape level indicators are a cumulative indicator, so it doesn't necessarily pinpoint specific changes. So I just wanted to show you one case. There's actually examples of this in all three of my sites, but this is one of the more interesting ones where you have shoreline activities having a fairly clear direct impact on the eelgrass over time. So this is Horton Bay, and each of these frames show you the change between two consecutive mapping years. So, for example, the 1932 to 1950, you have areas that are black, areas that are red, and areas that are blue. So the black areas are where eelgrass remain the same from 1932 to 1950. The red areas are where you had eelgrass loss, and the blue areas are where you had gain or expansion in eelgrass. And so Horton Bay has these two fringing arms that go along the north and the south side of the bay. And what we're going to look at is what happens to Horton Bay in the north side of the bay. And you see in 1932 to 1950 that fringing eelgrass along the north side of the bay is intact. In the next frame from 1950 to 1975, it's still intact, but you start to see some boats, and the boats are the little blue dots kind of in the northeast side of the bay. And the reason that they're congregating right there is because that's the closest spot to the road access to get into town. So it's the closest place to park your boat to get to shore. There's also a dock that goes in there, with one boat parked at it as well. From 1975 to 2004, this is where we start to see some eelgrass loss occurring. So we have a huge number of boats that are present in the bay, and another dock where we see more loss occurring. And along that little strip between the boats and that road access, we've lost a fair amount of eelgrass. From 2004 to 2010, again, we see more loss of eelgrass in that fringing area. Another dock that goes in on the far west side of that little area, with more eelgrass lost around that dock. And then similar story going on in 2010 to 2016.
Can I ask a question?
Yeah, for sure.
My parents used to have a cabin in Horton Bay, so I know that area well.
Okay.
And nothing you've mentioned so far talks about the oyster farms that they have in there. Does that have any effect on it?
Likely. The oyster farms, as far as I know, they put them fairly deeper. I wasn't able to quantify that in...
I don't know if they're there anymore.
They were not there anymore.
Yeah, they were there for quite a few years.
Okay, so they weren't there, so I didn't think to ask anybody, and they might have looked like something else in air photos as well when I was analyzing it. So thank you. I will look into that one for sure. And so the conclusion of all this is that we have observed some eelgrass declines occurring in these sites in the Southern Gulf Islands, and considering that they are fairly undeveloped compared to some other places within the Salish Sea, it's likely that these declines are probable elsewhere. Of course, more investigation would need to be done to be able to say that for sure. But if this is the case and that the declines are more widespread than just this little area in the Southern Gulf Islands, then definitely eelgrass habitat loss could potentially play a role in low survival of juvenile salmon. And finally, I just wanted to say thank you very much for your support.